Hello students, I am Lekajit Oza and today I am going to show you how to solve the MCQs of chapter 1, first chapter, real number of mathematics for class 10, and this video is going to be very helpful for those students who are going to appear HSLC exam. Okay, so before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends since we're going to create new contents for you. Okay, so now let's start. So here is the first question, the exponent of 2 in the prime factorization of 144. So here you see what will be the correct answer. If you factorize 144, so what will be the prime factorization of this? So here 72, then if you divide it by 7 again, then it's going to be 36 again. It's going to be 18, then again 9 times, then again 3. So what will be the exponent of 2? So how many 2's are there? 1, 2, 3, 4. So correct answer is option A, that is 4. So that will be the exponent of 2 in this prime factorization. That means we can write 144 is equal to 2 to the power 4 into, so 3 into 3, that is 3 square. So exponent of 2 is 4 now here. So that is the answer, right? So hope you have understood this. Now let's move on to the next question. What is the next question here? LCM of two numbers is 1200. There are two numbers, LCM is 1200, and which of the following cannot be their HCF? Now you see, remember one thing, that LCM of any two numbers is always divisible by their HCF. Okay, so now you see, so which of the following number cannot be HCF of this those two numbers? Okay, LCM of those two numbers is given 1200, but we need to find the possible HCF of those. Out of these four numbers, which one is possible? Possible HCF of those two numbers that must divide the LCM of those two numbers. That means they must divide this 1200, right? Okay, the HCM must divide that LCM of the two numbers. Now here you see, if you see that 1200 is divisible by 600, okay, if you 2 times it, right? But it is not completely divisible by 500. 1200 is also divisible by 400 and 200 as well, but not divisible by 500. So 500 is not possible. It cannot be HCF. Okay, so that's why our correct answer is B. Answer is B, that is 500. Okay, that is 500. Okay. So now let's move on to next question. What is the next question here? You see, n is equal to 2 to the power 3, 3 to the power 4, 5 to the power 4, 7 into 7. Then the number of consecutive zeros in this. So how many consecutive zeros are there? So that means, now what do you mean by consecutive zeros? Suppose you have a number, suppose 1600. So there are two consecutive zeros. Okay, so that means we have to find, if we multiply these numbers, so how many consecutive zeros will be there at the end. So how to find it? You see, and numbers to be ended with zeros, it must be divisible by 2 as well as 5. Okay, so that's why here you see, check the factors 5 and 2. So here we have 2 to the power 3 and here we have 5 to the power 4. So here we have both 2 and 5, but to be to end with 0, we know that 2 5s are 10, right? 2 5s are 10. So there is 5 to the power 4, but there will be 4 5s and there will be 3 2s, but there are only 3 2s. Okay, so that's why if you multiply 3 5s with them, then you're gonna get 3 10s, right? Okay, but 1 5 will be left out because there is no no other 2 to multiply with the 5 multiplied by 5. So that's why, so number of consecutive zeros will be 3. So here this B is the correct answer. So though I have explained this, you may think it is very long or very confusing. So just let me tell you something. So just check the exponent of 5 and 2, which one is less, that will be the answer. Okay, that's it. So question number 4, the sum of the exponents of a prime factors of the prime factors in the prime factorization of this number 196 is, so which option is correct? So first check the prime factors. Okay, 196, so that can be okay, let's factorize this. Okay, that's what we got. So here you see we have 2 to the power 2 and we have 7 to the power 2, and sum of the exponents 2 plus 2. Here is the here exponent is 2, here also exponent is 2. So correct option is 4, right? C is the correct option. So 4 is the correct answer, right? And next one you see question number 5, the number of decimal places after which the decimal expansion of this number will terminate. So here you see the decimal expansion of a real number to be terminating. So the denominator must consist only 2 and 5. Okay, 2 to the power something and 5 to the power something. Okay, that means denominator should be of this form, 2 to the power n and into 5 to the power n of this form. Okay, so and if there is any other number, suppose 3, if this number doesn't divide the numerator, then that cannot be terminating. Okay, so if the number which is other than 2 and 5, if there is any other factor other than 2 and 5 in the denominator, like 3, 7 or something else, if those numbers can cancel the numerator, then it can be terminating. Okay, so now you see, if that is the case, now here you see it is clearly there, this is in this form 2 to the power n and 5 to the power m. So now check that if there any other cancellation possible or not. Can 2 cancels this? No. 5 also cannot cancel this. In that situation you don't need to do anything else. Check the powers. Check the power on which either 2 or power of 2 or 5, which one is greater. So here power of 5 is 1, okay, and here power on 2 is 2, so 2 is greater, so that's why answer will be 2. So after 2 digit it will terminate. The option B is okay. B is the correct option, because you see 23 by 2 to the power 2 into 5 to the power only 5 to the power 1. So to make to express this in decimal form, what we're going to do, we're going to make it 5 square, then we have to multiply here also 5, then when it cancels it gives again again the original number, right? Hope you have understood this. So then what we're going to get, so 15 1 carry 10 11, then it's gonna be 100, right? So here you see, so this is terminating after 2 digits. Okay, so 2 digits after decimal, right? So you don't need to do these things. Okay, just you need to check out of 2, or you have to compare this. You see, if the denominators is in this form 2 to the power n and 5 to the power n, now check which one is greater. If the power on 5 is greater, if m is greater than n, then your m gonna be the answer. That means after decimal there will be m number of digits, and if n is greater than m, right, then after decimal there must be n number of digits. That's it. Okay, so hope you have understood this. Now let's move on to the next question. So here is the next question, question number 6. P1 and P2 are two odd prime numbers such that P1 is greater than P2, then P square minus P2 square. So how to do this? This gonna be even, odd, or what? That has to be determined here. To explain this, let me give you an example. Suppose P1 is 7 and P2 is let me take 3. Okay, these are odd prime numbers. These are odd prime numbers. Okay, now you see P1 square minus P2 square, that's going to be 7 square minus 3 square, so 49 minus 9, so that is 40, which is even. So that's going to be even. Option A is correct. Okay, right? So now let's move on to the next question. So here is the next question, question number 7. If two positive integers a and b are expressible in terms of a is equal to, suppose here a is equal to p into q square and b is equal to is given p cube q, and p and q, these two are prime numbers. Okay, so what going to be the LCM of a and b? So how to find the LCM of a and b? LCM of a and b. So here you see, here we have p and q, here also we have p and q. So take the highest power of p and q. So here you see we have p cube, so let us take p cube. Here we have p to the power 1, so instead of p to the power 1, we're going to take the p with greater power. And similarly here we have q square, here we have q only, so we're going to take q square, so q square. So this is going to be the LCM. Okay, this is the correct answer, option C. Suppose if the question is asked to find the LCM, instead of LCM you need to find the ACF, then you have to take the least power, p with least power and q with least power, that means the lowest power. So let me go back to the next question. Here is the question. You see, in question number 7, that means in the same question, a and b, for a and b which are equal to pq square and p cube q. A is this, b is this, and from here we need to find the ACF of a and b. So as I have already told you, so we're gonna take the lowest power of p and q. So a is, here you see p q square, and here we have p cube q. So lowest power, p with lowest power is only p, and q, here is q to the power 1, that means here q is the lowest, q to the power 1 is the lowest power. Okay, 1 is the lowest power of q, so ACF gonna be pq. So here A is the answer, right? Now question number 9. Here you see, if two positive integers m and n are expressible in terms of this and this. So m is equal to here p q cube and n is equal to p cube q square. That's what we have got. And then what going to be the ACF? So here we have p, here also we have p, but here the power is 3 and here power is 1. So take the smallest p with lowest power, that is p only. And similarly q cube, here q square, so take the q with its smallest power, that is q square. So this is the ACF, p q square, right? So B is the correct option. So hope you have understood this. Next question is question number 10. If the LCM of a number a and 18 is 36, a and 18 is 36, and ACF of a and 18 is 2, ACF and LCM are given, then what is the value of a? So we know that LCM and ACF of LCM of a and 18 is given, that is that is 36, and ACF of a and 18 is given, that is 2. We know that product of LCM and ACF is equal to the product of the two numbers, right? Product of the two numbers. And what are the two numbers? A into 18. A and 18 are the two numbers. So that's why. So what going to be the A? A is equal to LCM into ACF divided by 18. So LCM is 36. ACF is 2 divided by 18. 18 cancels 36, gives 2. 2 to the 4. So 4 is the correct answer. Option is C. Correct option is C. Right. Now let's move on to next question. So next question is question number 11. Here ACF of 95 and 125. We need to find the ACF. So first you can apply division method, or you can apply the prime factor you want. Okay, so let me show you the division method. 152, if you divide it by 95, so then what you're gonna get? So you cannot give 2 times here. If you give 2 times here, you're gonna get 190. So that's why let's give 1 time. Okay, so then here we're gonna get 95, right? And then here it is 7, that's 14, so here we're gonna get 57. So now let's divide this number 95 by the remainder we have got here by 57. Okay, then again 1 time 57, then here we're gonna get 8, so 38, then 57 divided by 38, so again 38, so it's gonna be equal to 9. Here we're gonna have 19. So now divide 38 by this remainder, so 2 times, so 38. So you have to continue dividing unless and until you get 0 remainder. Okay, so before that, what you by which number you have divided? 19. So 19, option C. So this is the correct option, right? So hope you have understood this, or you can apply the prime factorization method as well if you want to apply. So now let's move on to next question. Here is the question number 12. So HCF of these two numbers is 13. We need to find the LCM. That's very simple. Again we're going to apply this, that LCM into HCF of two numbers is equal to the product of LCM and HCF is equal to the product of the two numbers, right? So that's why we need to find the LCM. So here we're going to write product of the two numbers, that is, what are the two numbers here? 26 and 196, sorry, 26 and 196, and divided by HCF. So divided by HCF is 13 here, so this cancels. 2 times into 196, that's gonna be this 338. So this is the correct option, right? So now let's move on to next question. Question number 13. Here A is equal to 2 cube into 3, B is equal to 2 into 3 into 5, C is equal to 3 to the power n into 5. So LCM of this A, B and C is equal to this one. Then what is the value of n, right? What is the value of n? So here we have A is equal to 2 to the power 3, right, into 3. B is equal to 2 into 3 into 5, and C is equal to 3 to the power n into 5. Now LCM is given, that is 2 to the power 3 into 3 to the power 2 into 5. Okay, now you see, as I have already explained how to find the LCM. In order to find the LCM, we're gonna take the factor with highest power. So here we have 2 cube, so here also we have 2 cube. Here 5 to the power 1 is the highest power of 5, 1 is the highest power of 5, so here we have 5 only. And here this is 3, so here it is 3 to the power 1, 3 to the power 1, here 3 to the power n. So as we have 3 to the power 2 here, so 2 must be the highest power, and this is 1, so the n must be equal to 2. Then only here we're gonna get 3 to the power 2, because in HCF we're gonna take the highest power of 3, that is 3 to the power 2, if that is the highest power. But here you see, here we have 3 to the power 1 only, so here also we have 3 to the power 1 only. So only possible thing is that this is 3 to the power 2, that is the possible value of 2. Otherwise here we cannot write 3 to the power 2, because here we have only 1, here only 1, so only last option is our n is equal to 2. So this is the correct option, right? B is the correct option, so its value is 2, right? Hope you have understood. Decimal expansion of the rational number, this one divided by this one, will be terminate after. So first 1 4 5 8 7, then 1 2 5 0. First let us take the denominator. First see the prime factorization of this denominator. Here 1250, so divided by 2 6 times, then 2 times, then 5, then again divide it by 5 times. So we already know that 6 to the power 625 is 5 to the power 4. So prime factorization is 2 into 5 to the power 4. So here 2 to the power 1. So this is in this form, 2 to the power n into 5 to the power n, right? And this is not divisible by 2 and also not divisible by 5. So that's why here you see, in this case what we're gonna take, as I have already explained, that if n is greater than m, then after decimal n number of digits, okay, and if m is greater than n, then after decimal there will be m number of digits. So here this 4 is greater than 1, so that's why after decimal there will be 4 place. So D is the correct option, right? So next question, 15. P and Q are co-prime numbers. Co-prime means they have no common factor other than 1. P square and Q square are co-prime, not co-prime, even, odd. So here you see, let me tell you one thing. If you have two numbers co-prime, suppose 3 and or let us take 4 and 5, whatever you take, 3 and 5, 4 and 5. So these numbers have only one common factor, that is 1. Other than 1, they have no any other common factor. In that case, you see, if you take 4 to the power 2, 5 to the power 2, if you take 4 to the power 3, 5 to the power 3, and doesn't matter what is the power on 4, what are the powers of 4 and 5. If these two are co-prime, then these two must be also co-prime, these two must be also co-prime, okay? So if you want to check, then you can check. Just take its square, and its square is 25. So if you see, this two also have only one common factor, that is 1, okay? So that's why they are also co-prime. They are also co-prime. A is the correct option. Now next question, which of the following rational numbers have terminating decimal? To be terminating, we know that the denominator must be of this form, 2 to the power n and 5 to the power n, right? So if that is the case, so here you see, so 225, this can be written this way. First let me write here 16 2 to 5, okay? First let us factorize this 2 to 5. What are you gonna get, right? Then right, and 3 into 3. So now you see, so prime factorization of 225 is 5 to the power 2 and 3 to the power 2. And if now you see, this is not in this form, 2 to the power n into 5 to the power n, okay? So if you get only 5 to the power m, then also it gonna be then also it is terminating, okay? Or if you get only 2 to the power n, then also it is terminating. But you should not get any other number as factor other than 2 and 5, okay? If you get, then it must cancel the numerator, but here you know, this 3 square cannot cancel 16, so that's why this is not terminating, okay? Now let me check this one. 5 by 18. 18 is nothing but, you know, 2 into 3 into 3, and 3 does not cancel 5, right? So that's why this is also not terminating. So here you see 2 by 21, 2 by 21. So here 2 by 21, 2 by 21. 21 is, you know, 3 7s are 21. It is obviously not terminating. And here 7 by 225, 7 by 2, sorry, not 225, 250, right? So 250 means you know, 250 is 25 into 10. 25 is 5 square, 10 is 2 into 5. So here we're gonna get 5 to the power 3 into 2. So this is in 2 to the power n into 5 to the power m form. So that's why it is terminating. So here only 4 is terminating. There is no any you know, correct option. So there must be a printing mistake. So only 4 is the correct. Okay, this is the terminating only. Right. Next one. 18. Question number 18. Here you see 3.27 recurring. 3.27 recurring. It is an integer, it is a rational number, it is a natural number, it is irrational number. You know, recurring numbers are rational numbers, okay? Those are rational numbers, right? Now root 27, so what should be multiplied to this number, the smallest number to be multiplied by this to make it rational. So root 27 means root over 3 into 3 into 3. So root 3 is irrational, so to make it rational, so we need to multiply. If you multiply root 3 with this, then what you gonna get? Then you're gonna get 3 into 3 into 3 into 3. So then you're gonna get 3 into 3, okay, which is 9, which is rational. So the correct option is root 3. Next question. The smallest rational number by which this should be multiplied so that its decimal expansion terminates after one place of decimal, right? So now you see this is 1 by 3. If you multiply 3 here, then you're gonna get 1, so which terminates, but after decimal there is no digits. So but here we need one decimal place, right? One place of decimal. So that's why what we can do here, we can multiply 3 by 10. If you multiply 3 by 10, then 3 here will be cancelled, then you're gonna get 0.1. Now here we're gonna get one decimal here. So that's why the correct option is 3 by 10. Okay, 3 by 10, right? So if you multiply 3 by 100, then you're gonna get 2 decimal places. Okay, so that's why we need only one place of decimal. So that's why option A is correct. So next question. N is a natural number, then 9 to the power twice n, 4 to the power twice n is always divisible by. So 9 to the power 2n minus 4 to the power 2n is always divisible by. So now here you see, if you have a number of this form, a to the power twice n and minus b to the power twice n is always divisible by a minus b and a plus b, right? So here instead of a and b we have 9 and 4. So 9 minus 4 and 9 plus 4. So 9 minus 4 is 5, 9 plus 4 is 13. So which option is correct? So both 5 and 13. So option C is correct, right? So now let's move on to next question. Now you see, if n is any natural number, that is 6 to the power n and 6 to the power n and 5 to the power n always ends with. Now you see, doesn't matter what is the power on 6, 2, 1, 3, 4, that's gonna be always that's always gonna end with 6. Suppose you have 2 square, that's gonna be 36. 6 square 36. Suppose you have 6 to the power 3, then it's gonna be 36, 3 carry 8, 216. Okay, and you may check 6 to the power 4, 6 to the power 5, and so on. Those numbers gonna be ending with 6. Similarly 5 to the power n, that also ends with 5, right? So that's why now you see, as they ends with 5, now let's take the ending numbers. So 5 minus 6 minus 5, that is equal to 1. So that's why your answer is 1. Simply just 6 minus 5, right? Now you see, LCM and HCF of two rational numbers are equal, then the numbers must be also equal. Now you see, if you take two same numbers, then only you gonna get LCM and HCF equal, otherwise it is not possible, right? Okay, so now you see, next question is sum of LCM and HCF of two numbers is this. Their LCM is this, then what will be their HCF? Sum of the LCM and HCF, let us take LCM is suppose x and HCF is suppose y, and their sum x plus y is equal to 1260, and LCM is 900 more, that is x is 900 more than y, than HCF, right? So if you solve these two equations, then what you're gonna get? Replace this x by this value, then you're gonna get 900 plus y plus y is equal to 1260, then twice y, that's going to be equal to 1260 minus 900. Then if you divide it, if you subtract this, then what you're going to get? 360, right? And then y is equal to 360 divided by 2, that's going to be 180. So y is 180. Now let's find the x. So let's put the value of y here. X is equal to 900 plus y, that is 180. So then we're going to get 1080. That is the LCM. So what we need to find? We need to find the product of the two numbers. Product of two numbers is equal to the product of their LCM and HCF. So now LCM is 1080 and HCF is 180. So multiply these two, 1080 and 180 and 180. Then what you gonna get? 64. Then this. Then what we're gonna have here? Okay. So here we're gonna get 0801, right? So that means 004, then 4, 1 carry 19, this. So that is what we're gonna have. So here B is the correct option, right? So hope you have understood this. Now let's move on to next question. Next question 25. The remainder when the square of any prime number greater than 3 is divided by 6. So prime number, square of any prime number greater than 3 divided by 6. So let me take that prime number, suppose 6k plus or minus 1, right? Where k is the natural number, it may be 1, it may be 2, it may be 3. Okay, so and we need prime number greater than 3. Okay, to be greater than 3, so here we must take at least 6k plus 1 or minus 1, because we know 6 minus 1 is equal to 5, which is the next prime number after 3. Okay, so if k is 1, 6 into 1, then minus 1, that's going to be 5. So it is not necessary that it must be always 5. So that's why there are infinite number of prime numbers which are greater than 3. So I have taken this form, and its square, if you take the square, then it's going to be 36k square, and then plus minus root over 2 into 6k, then 1, then plus 1 square, right? That's what we're going to have. So from these two, if you take what you can take common, you see, if you take 6k common from these two, 6k, then within bracket 6k plus minus, you're gonna have 2k, right, and plus 1. So this part is divisible by 6, then 6, you have a number divisible by 6, then you have plus 1, that means the remainder must be 1. So A is the correct. So we're going to solve more questions in the next video. Okay, so I don't want to make this video too long. So so do subscribe the channel and hit the bell icon so that you get notified when the next part will be uploaded. Okay, so thank you for watching. See you in the next video.